Hello, viewers. In today's session, we are going to discuss two important problems related to finding out the range of functions. Right? So, let us first take this problem in which we have to find the range of the function f of x, which is equal to tan inverse square root of 3 times cos x raised to 4. So now let us take this function as y is equal to f of x. And we know that all the valid values of x gives us the domain, and the corresponding values of y gives us the range. So suppose we have a function from set A to set B, and here we have the set A and here we have the set B. Then if we define a function f from a to B, then here we have x, that is x is in the domain, and if this x is mapped with some number, say y, which belongs to this set B, then y gives us the range. So now to get the range of this function, we'll start with the cos x raised to 4. So here we know that the cosine function, that is the range of cosine function, is from -1 to 1, right? So here we have cos x raised to 4. So it is obvious and clear that cos x raised to 4 is always going to be a positive quantity, because here we have the even power, right? So cos 4, that is cos x raised to 4, is always going to be greater than or equal to 0, but it is less than or equal to 1. So from the range of cos x, we have this inequality, right? Because here the cos x has the power 4, and which is even. So cosine 4x is always going to be positive. So cosine x raised to 4 is always, it always lies between 0 and 1, including 0 and 1, right? So now let us multiply this inequality with this number, that is the square root of 3. So what we will get here, we'll get 0, and here we have square root of 3 cos x raised to 4, and here we have square root of 3, right? Okay, so now what we will do, here we have inverse of tan, that is tan inverse. So what we will do, we'll take the tan inverse of all these three quantities. So we have tan inverse 0, then we have tan inverse square root of 3 cos x raised to 4, and here we have tan inverse square root of 3, right? Now see here, it is important to note that the direction of the inequality, it doesn't change, because the tan inverse function is an increasing function, because the derivative of tan inverse x is 1 over 1 plus x square, and 1 over 1 plus x square is always going to be greater than 0 for all values of x belonging to the set of real numbers. So the inverse of a tangent function is an increasing function. So now tan inverse 0 is simply 0, and here this quantity is now equal to f of x, and here we have tan inverse square root of 3, and we know that tan pi by 3, that is tan 60 degrees, is equal to square root of 3. So pi by 3 is equal to tan inverse square root of 3. So here we have pi over 3, right? So the range of this function f of x is given by the interval that is from 0 to pi by 3. Now let us consider this problem in which we have to find the range of this function f of x is equal to sine pi by 3 sine square x. So to get the range of this function, we'll start with this quantity, that is sine square x. Now from trigonometry, we know that the range of sine x function is from -1 to 1, right? And here we have sine square x. So when sine x, it belongs to the interval that is from -1 to 1, then sine square x belongs to the interval that is 0 to 1, because sine square x is a square term, so this is always positive, right? So sine square x is it is lying between 0 and 1, right? So we have sine square x lying between 0 and 1. So now what we will do, we'll multiply this inequality throughout by pi by 3. So multiplying it by pi by 3, we have 0 times pi by 3, then we have pi by 3 sine square x, and then here we have pi by 3 times 1. So this is 0, and here we have f of x, and here we have pi by 3, right? And f of x is, if we take y is equal to f of x, then we have y ranging from 0 to pi by 3. So the range of this function f of x is given by the interval that is 0 to pi by 3.